Welcome back to another Daishinfinity video. In this video, we're going to talk about the sum of all natural numbers. I'm going to prove the formula of the sum of all natural numbers, or like if you want to say it, deriving the formula. It's not proven by me, it's proven by a mathematician called Gauss. He was a German and he proved this formula when he was 6 or 7 years old. So he was a very smart boy. And I'm going to talk about the natural numbers first so that we would understand the formula. To understand this formula, let's talk about the natural numbers. The natural numbers is a set of all numbers from 1 to infinity. So we have 1, 2, 3, 4, 5 and so on until infinity. So I'm not going to put in infinity because this is an incorrect way of writing. And if we would want to sum all the natural numbers up from 1 to infinity, it will look like this: 1 plus 2 plus 3 plus 4 plus 5 and so on up to infinity. And logically speaking and theoretically speaking, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and it will get always bigger, which means this sum will diverge. Okay, so it will go to infinity. It will approach infinity for the limit as the natural numbers approach infinity. But one mathematician called Ramanujan from India solved this problem and proved that it is minus 1/12, which is very mysterious. I'm going to talk about this sum formula from Ramanujan in another video, but for this video, for this sake, it's not very important to talk about this sum. Now, today we want to talk about the sum where k goes from 1 to n of k, which is going to be 1 plus 2 plus 3 plus all the way up to n. Okay, this is the formula we would need, and we would want to have a general formula with respect to n. Okay, and I would like to prove this formula, that this formula is equal to n plus n times n plus 1 divided by 2. So let's take this whole formula and paste it here. Okay, and let's call this sum S as a sum. Okay, now what did Gauss do? Gauss was very 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 smart, and he represented the sum in another way. So he just started with n because it doesn't really make a difference. So I just say, okay, I have n, and the next number is one number down and then n, so n minus 1. Then second number, the third number is n minus 2, and then so on until we get 3 plus 2 plus 1. Okay. Now, how many numbers do we have here that are added? Exactly n numbers, right? So we have n numbers. Now the trick he did is, when we have the same set, the cardinality of the set, if it's the same, over here the s is a variable, but the cardinality, if we talk about the theoretical side, the cardinality and the set is the same over here. So we can add those two up. This is what Gauss did, and he saw that if I add the simple n and the simple 1 and the simple 2 and the simple n minus 1 and the simple 3 and then the simple n minus 2 and so on and so forth, if we add all these up, okay, we would get n plus 1 plus 2 plus n minus 1, which is n plus 1, and 3 plus n minus 2, which is also n plus 1. And we will get that how many times? We just talked about it. Exact n times, okay? And since we added those two equations, we have to add on the right side too. So s plus s equaling 2 times the sum. Now, since we have 2 times the sum is equal to the n times of the sum of n plus 1, we can just say we have n times the n plus 1s, right? And this is equal to 2s. Now s is like x, and we want to solve for x. So let's divide both sides by 2, leaving us with n times n plus 1 divided by 2 is equal to s. Now this is the formula for the sum of the whole natural numbers up to n. So I just proven this formula, and it's actually not that hard. Yeah, thanks to Gauss's theory. And I thank you guys for watching this video. And in the next video, I'm going to talk about the geometric sum of this sum. So the geometric way of representing this sum. Thank you guys for watching. Like and subscribe. Comment on the video if you have any questions or recommendations. And see you in the next Daishinfinity video. See ya.